Hello again, my name is Osman Abubakar. I am here today to take you through the concept of two externally tangent circles. Now, we are asked to find the distance between A and B, which is S. And these two circles are called two externally tangent circles because they are two circles intersecting on the outside and they are lying on a common line, each having the point of tangency. So when you look at the bigger circle, this is the point of tangency. This smaller circle has B as its point of tangency. So we are going to look at this. Please pay attention and follow me. Now, there are two things happening here. One, when we are able to connect the center of each of the two circles to their respective points of tangency, they are the radius of each circle. So we are going to say that when we connect the center here to the point of tangency, okay, so it becomes the radius of the bigger circle, and this radius is perpendicular to this tangent. Okay, so we can name this capital R, that is radius of the bigger circle. Then we can do the same thing here and call this one small r. This is also perpendicular to this tangent. Now the second thing which is happening here is that these 3 points, that is the center of the bigger circle, the point of intersection of the two circles, and the center of the smaller circle are all lying on a straight line. It means that we can draw a straight line through these 3 points. Now watch. And it happens always, no exception. So we have this. All right. Now we can say this is C, this is D. Now we can draw another line, and that line must be parallel to line AB. That is parallel and equal to line AB, so that we can take that line from here. Okay, we can take it here. That is from the radius of the bigger circle to the radius of the smaller circle. Good. Now this line is equal and parallel to line AB. Hence, if this is AB, which is S, then this one is also S. Then we can put E here. All right. Now look closely. If this radius, which is BC, equals R, and it is equal to AE, and watch, it is equal and parallel, then we can also say this is small r. All right. Now if the whole of this is capital R and this alone is small r, then when we're able to subtract small r from capital R, we'll get ED. Therefore ED is going to be capital R minus small r. All right. Now you agree with me that whenever we are able to draw a straight line from the center of a circle to its circumference, we have a radius. Therefore this is also a radius of the bigger circle. We can name it capital R. The same thing here. This to this point is the radius of the smaller circle, which is small r. Now this line that we drew here is perpendicular to line AD. Therefore we have a right angle here. Now we have a right angle triangle CDE. All right, so we can draw that right angle triangle here beautifully. All right, so when you look at it carefully, this point becomes our E, where we have the right angle. Then this is our D, this is our C. Now ED is capital R minus small r. Let's put that in parentheses. And then EC or CE, this is EC or CE, is S. Now when you go to the diagram, the whole of this line, which is DC, comprises capital R and small r. So when we add the two, we have line DC. So that DC will give us capital R plus small r, like this. All right, now you know what we are going to do. We are going to apply Pythagoras theorem, so that this hypotenuse squared equals this longer leg squared plus the shorter leg squared. So r plus r squared equals capital R minus small r squared plus s squared. Now, without wasting much time, let's quickly expand this using the shorter approach, so that you say that square the first r squared twice the product of the two capital R small r square the last plus r squared equals the same thing here. Square the first r squared twice the product of the 2 minus 2 capital R small r square the last plus r squared. Then we have plus s squared. All right, let's group like terms. When we group like terms, you agree with me that this will cancel that, and then this will delete that, so that we have this 2 capital R small r. This is negative version of this. When it crosses the equal to sign, it becomes positive. So plus 2 capital R small r equals finally s squared. Okay, so that this will give us 4 capital R small r equals s squared. Now let's rewrite them. So s squared equals 4 capital R small r. All right, here we are clearing the square. So we put square root here, square root there. This square will cancel the square root. Finally, s is standing alone equals. Now you remember this. Let's go here. If you have square root of a times b, or ab, is the same as square root of a times square root of b. Now we are doing the same thing here, so we can separate them or split them, so that square root of 4 times square root of capital R small r. All right, then s equals, this will give us 2. That is square root of 4 is 2, then root capital R small r. So at any point in time when you have such a problem, two externally tangent circles lying on a common tangent, then the distance between the 2 points of tangency is undoubtedly 2 root r, that's capital R times small r. Now let's do this. Assuming you were given capital R equals 9 centimeters and small r equals 4 centimeters, you can put the figures here and then solve it, use or follow the process used in arriving at the formula. You get the answer. Or once we know the formula, we only substitute the values. Now we are told that r, that is capital R, is 9 times small r is 4. Okay, so we can separate them. You can put 2 here and then put bracket here. Say that root 9 times root 4, like this. All right, so s equals, I'll put my 2 here into bracket. Root 9 is 3 times root 4 is 2, so that s equals 2 times, this will give us 6, so that s equals 12 centimeters. Now at any point in time when you have such a problem, you can put the values there, solve it procedurally, you arrive at the same answer, or you prove the formula, you only plug the values into the formula and solve. Finally, this is what we have done. This concept is called the concept of two externally tangent circles. Go through and help yourself. Once again, my name is Osman Abubakar. Thank you.